Okay, on this problem it says get the rate of change in cancer cells in 2 days after treatment for the function n equals negative 2t squared minus 3t plus 10, where n is the total number of cancerous cells in thousands and t is the number of days after radiation treatment. So to get this rate of change at this particular day, you have to use the difference quotient and get the limit as h approaches 0. So we have to do n of t plus h minus n of t over h. It's very similar to what we had before, f of x plus h minus f of x over h. The x in this case is t, that's the variable we're dealing with, and the function is an f of t, it's n of t. So first of all, we've got to get n of t plus h. So everywhere there's a t on this function, put a t plus h. Well, n of t plus h is going to be negative 2 times t plus h, that gets squared. This is composition of function here. T plus h, that gets squared, minus 3 times t plus h plus 10. And working this out, this would be negative 2 times, well, t plus h squared, t plus h times t plus h. If you FOIL that together, you'll get t squared plus 2th plus h squared. Okay, write t plus h and then put parentheses another t plus h, and you FOIL that together, you will get this. Now distribute the negative 2 through, and if you take the negative 2 through right here, you get negative 2t squared minus 4th minus 2h squared. And the rest of this right here was a minus 3t minus 3h, and then your plus 10. So that's what n of t plus h is. That's this bit right here. Now, that's this bit. We have to take that bit, the n of t plus h, and subtract off the original function. So here's the n of t plus h right here. Okay, that's what we just got right there. That's this bit right here. And then we have to subtract off the original function. So subtract off, don't forget, minus parentheses, the original function right here. Put that right there. And then all that is divided by h. Looks like a huge mess, but a lot of stuff cancels out. When you take this minus sign through, you'll get plus 2t squared plus 3t minus 10. See, the minus is going to change every sign in here, making it plus 2t squared plus 3t minus 10. Now, this 2t squared cancels out with that minus 2t squared. This minus 3t cancels out with that plus 3t, and this plus 10 cancels out with that minus 10. So the only thing you're left with is the minus 4th minus 2h squared minus 3h all over h. Well, at this point, an h factors out of the top. And if you factor an h out of the top, you have this. The h's then divide out, and we just have minus 4t minus 2h minus 3. Now, that's my difference quotient right there. The slope of my difference quotient, if you have a question that asks that, is this right here. Here's your slope of the difference quotient, negative 4. Okay, negative 4 is the slope of the difference quotient. Now it says we need to find the limit as h approaches 0 to get the slope of the tangent line. So if you let h equal 0, that cancels that bit out, and all you have is minus 4t minus 3. Minus 4t minus 3. Now, we want to get the rate of change in cancerous cells in 2 days. So just substitute the 2 in for t. If we do that, 2 times negative 4 is negative 8, and negative 8 minus 3 is negative 11. So therefore, at day 2, the number of cancerous cells were decreasing by 11,000 per day. Why decreasing? Well, it's negative 11. This is telling you how quickly it's either going up or down. The negative means it's going down by 11. And the units on this original problem was in terms of thousands. I'll show you that here again. Where n is the total number of cancerous cells in thousands. So this tells me that the number of cancerous cells due to this radiation treatment is going down by 11,000 per day. That's great. Then we can use this then to get the rate of change at any time. We can get the rate of change of cancerous cells at any day by substituting that day, day 1, day 2, day 3, whatever, into this function right here that we just derived, negative 4t minus 3. Now that same problem done on Excel is very easy, but you won't get your individual pieces. Like we won't know if a question says, what's the slope of the tangent line? Here we know what it is. It's -4. But we can do it on Excel, and I'll show you how you do that. The original function, again, is this right here, -2t minus 3t plus 10, -2t squared minus 3t plus 10, and putting that in on the Excel sheet. Let's do that up here. So my coefficients are -2 on the quadratic sheet, -2, -3, and 10. And we just wanted how quickly are the cancer cells changing at day 2. So go down here, put a 2 in, you get -11. And that's what we got. I mean, it's so quick right there. And that's what we got when we actually worked this thing all the way through. We got that. Okay. So right here, we got that it's -11. Here's another one. Find the difference quotient for this function and find the average rate of change between the x values going from 3 to 6, 3 to 5, 3 to 4. Well, that's really a review of section 1.4 where we were doing this stuff. Let me go ahead and do some of this. It's quadratic. The coefficients are 2, -3, and 4. So let me put that in there. 2, -3, and 4. 2, -3, and 4. So those are in there. And then if you want to find the average rate of change from 3 to 6 right here, well, that's where we were doing this from day 3, or from x equals 3 to x equals 6. And that's where we put this formula in here, where we subtract off equals parentheses, the y value subtracted divided by the x value subtracted. So that tells you your average rate of change from day 3 to day 6. And then it also said 3 to 5, 3 to 4, and then exactly at 3. Well, let's check. Here's 3 to 6, and it's 15. 3 to 5, it's 13. 3 to 4, it's 11. 3 to 3, I can't really do that. Say it's division by 0. But you can see that from 3 to 6, it was 15. And 3 to 5, it went down to what? 13. It went down 2. Here, 3 to 4, it went down 2 more. So at 3, exactly at 3, it should be 9. Well, we can get that down here. Let's put it in 3, and we get 9. So that's the slope of that line at day 3. Okay, it's actually changing by if it wanted to know the slope of that tangent line, we would have to what we'd have to do is work out that function. So let's do a little bit of this. So I'd have to get f. I'll show you here. F of x plus h. Well, I'll pause it while I type this up. So if we were asked to do this problem by hand, or what is the slope of the linear function we get when we work out this limit as h approaches 0 of this difference quotient, we'd have to work it out by hand. The f of x plus h on this, put x plus h into the function, it would be 2 times x plus h squared, then minus 3 times x plus h plus 4. Okay? Working this out, the x plus h squared is x squared plus 2xh plus h squared. And then we have to take the 2 times it, and taking the 2 times that gives me 2x squared plus 4xh plus 2h squared. This right here, taking the minus 3 through, gives minus 3x minus 3h and plus 4. So this whole bit right here is what f of x plus h is. Okay? Then the f of x is the original function right here. And substituting these two into the difference quotient, we say it's all of this stuff, the f of x plus h, all of this stuff, minus the f of x, this stuff, over h. Well, what happens here is the minus 2x squared right here and the 2x squared cancel out. The minus of a minus 3x is positive 3x, and that cancels out with that minus 3x. And then the minus of 4, minus 4, and the positive 4 cancel out. So all you have left is the 4xh plus 2h squared minus 3h is all that's left. Now we have to divide that by h. An h factors out on the top, giving you this. They cancel out, and you just have 4x plus 2h minus 3. Now the last thing you do is let h approach 0. Put 0 in for h right here, and you get 4x minus 3. And then what is the rate of change at x equals 3? Well, put the 3 in for x, and you get 12 minus 3, which is 9, which is the exact same thing we got when we evaluated it down here. What we don't know, though, is if it says what's the slope of this difference quotient. Well, the slope of that difference quotient is 4. But to tell you the truth, it's always going to be 2 from this power times the leading coefficient. 2 times 2 is 4. That's the slope of that value right here. And in fact, this number right here just comes from this coefficient. So to go from here to here extremely quick, all you have to do is take these two numbers and multiply them together. 2 times 2 is 4. That'd be 4x minus 3. Bang. That's the equation of the difference quotient right there. So that's it, and then the slope of that difference quotient is 4. Same thing works all over the place here. It always works. Like down here, you could work all this stuff out on problem 20, or I can tell you that slope of that difference quotient is going to be, take the 2 times minus 3 and you get minus 6t, and then minus 6. No t on the next one. Minus 6. I guarantee you when you work that out, that will be what that difference quotient is. You don't get anything from that constant there. So it's 2 times negative 3 is negative 6. T, don't forget the t, is now to the first power minus 6. That coefficient right there. Then it says, what's the change at day 1? Well, you just put 1 into t. So it'd be negative 6 times 1 minus 6. And I get that that's 0. And I tell you, I'm sorry, that's minus 12. And just to double check it, let's do this problem right here on Excel. Negative 3t squared minus 6t plus 140. So putting those coefficients in, let's do it up here. Minus 3, minus 6, and I think it was a 140 was the constant. And if I go down here and get that rate of change at day 1, put a 1 in here, and I get negative 12, and that's exactly what I got right here. So here's the shortcut of getting it. You take the power times the leading coefficient with the variable to the first power, then minus the next coefficient, the linear coefficient, and that's all you do. And that's a shortcut, and so you don't have to go through all of this stuff up here. So I'll stop right there, and you can take it from there.